Welcome to CPE270 Product Design. This submodule will take us through the steps needed to design a chemical product. My name is Alison Nidoma. I'm a lecturer in the Chemical and Biological Engineering department here at Sheffield, and I will be taking you through this submodule. So to begin with, we're going to talk about the general overview of what is involved in product design. To start, I have an example. This is a little bit of a challenge here. So the situation is that a local media news station starts reporting that there's been a fish kill downstream of a coal-fired plant. And what happens is the coal-fired plant uses water from the river to scrub and clean the flue gas that's being emitted. And then this water is stripped of CO2 and returned to the river. Of course, it's going to be a few degrees hotter, and it's going to have a slightly higher concentration of CO2 and potentially some particulates. But most of this should be removed by the stripper. The power company wants to decrease all of the contaminants that are in that wastewater stream down to 20% of the current value. And you, as an engineering consultancy, have been asked to design the plant that's going to achieve this 80% reduction in contaminants in the wastewater stream. So where do you begin? Well, if you're like me, probably the first thing I would think about doing is looking at that stripper and seeing what's going on there. So we're going to have a CO2-rich stream of wastewater entering from the absorption column, and leaving is the CO2 lean water. And that's the water that's going to be returned to the river. And now, stripping the CO2 out of this will have steam, and it's probably a little more complicated than this, but as a basic schematic, this is what's happening with our stripping column. And the question is, why is the efficiency of the stripping column dropped? And you might think that perhaps some of the trays have fouling on them, or the inside of the column is starting to corrode. There could be unpredicted perturbations in the flow rates of the two inlet streams. This is kind of basically where a chemical engineer would generally start questioning. And what the apocryphal answer to this problem is that the consultant actually started asking around in the area and got in touch with an environmental firm that was able to report the summer was particularly hot. And in the high temperatures, the water was able to absorb less dissolved gases. And that's a function of Henry's law, right? So hot water holds less oxygen. And because the water was less oxygenated, the fish were dying. So that has absolutely nothing to do with the coal-fired plant, unless you want to be abstract here and say that the CO2 emissions are indirectly affecting global warming, which is true, but it's not a direct causality. And so what the plant did was basically make a huge donation to a local ecological organization and very publicly make this donation, and to start an advertising campaign explaining how temperatures were affecting local flora and local fauna. And so by educating the public, the coal-fired plant was able to sort of restore their good reputation. And I guess my moral here is that the customer doesn't always know what they actually need. So in this case, the coal-fired plant, the customer thinks they need a really expensive addition to their process. And actually, all they need is a little bit of marketing. So that's the take home from that. Okay, jumping straight into the chemical product sector. What are chemical products? as with most things, we have a little bit of a taxonomy. So we tend to break them up into 4 or 5 categories. So the smallest are the small molecules. And these are things like aspirin or metformin. They're single molecules that have some kind of functionality, and that is quite often pharmaceutical. Most of your APIs would fall in this category. Next off, we have commodity chemicals. And these are chemicals that are produced at large scale, things like detergents and paints and cleaners. Probably most of what you would call a chemical around your house falls into the category of a commodity chemical. Next up, we have microstructured chemicals, and we'll let this category include nanostructured chemicals as well. But it's any kind of chemical where the structure conveys the unique properties. And so a detergent certainly falls into this category because we know that detergents form micelles and encapsulate oil-rich dirt. But where you choose to market your product determines what category it falls into. So if you want to make a whole lot of product and sell it cheap and really earn your income from that magnitude, you'd probably push it more into the commodity chemicals sector. Whereas if it were a more expensive product and you wanted to really earn your money from the value add, you'd probably push it more into the microstructured chemicals market. And finally, we have devices. And these are all kinds of items like solar cells, thermistors, glucose sensors, things that work to detect some kind of a chemical change and actuate some kind of a response or a signal that indicates that chemical change. And last is this other category. And I've put this because I thought of a huge chemical product that's not included within the remit of these others, and it's software. So every time you use Aspen, you are definitely using a chemical product. But this other category could encompass other products. If you're choosing what sector you're going to market a product into, and it doesn't really fit into the first 4, you want to be careful because you need consumers to understand what that product is and how they'll use it. But if you have a unique selling point, you can probably market the novelty of not really fitting into a normal category. So those are the products that we're going to be looking at. And here's an example of some of these products. So I'm going to kind of quickly whiz through here. Metformin is a small molecule. And below that, we have a solar cell, a polycrystalline solar cell. You're seeing those polycrystalline domains, and that's pretty clearly a device. Next up, a football helmet. It comprises high-impact polystyrene, which is the microstructure that you're seeing in SEM underneath the helmet. And these little bubbles, these are actually polystyrene domains, and they're dispersed in a matrix of butadiene. Now, polystyrene is really hard. If you think about a CD case, that's usually polystyrene, and it's hard and brittle. If you think about rubber, rubbers are usually soft. So this composite of the polystyrene and the butadiene rubber makes football helmets both really strong and able to respond to stress without cracking. So this product is definitely microstructured because all of its value comes from that unique structure. Next to it on the right, we have another set of microstructured products. These are filters. I'll just put microstruct. And these are manufactured via a range of processing techniques. But the idea is you want to create pores of a particular size to exclude either solid precipitates or Sometimes you can even exclude very large molecules like proteins. You can get membranes that separate out proteins. So that's a huge sector. Below that, we have some kind of a biomolecule. And depending on what this is, we'll know where to put it in the scheme of product types. It could be an enzyme that goes into a cleaner, so that could be a commodity chemical. You couldn't really call it a small molecule. You could potentially call it a microstructured molecule if it were, for example, a protein giving foam to your beer. So we need to know a little bit more about this one to figure out how to sell it. To the right of that, you have an aerogel. And these are those materials that are something like 99% air and just 1% solid. And so what you see is that a person doesn't feel a flame on one side of the surface going through, a centimeter thick of this material. That's because it has a very, very low thermal conductivity because it's mostly air, and air has low thermal conductivity. So this material gets all of its commodity value from being microstructured. To the right of that, we have a water bottle. It's technically nanostructured, but because PET is such a common plastic and so bulk, we'll just call it commodity. And the same with the paint above it. Paint is microstructured, but you sell it in large volumes, so it generally goes into the commodity category. So you can play this game at home, like just look around and see what kinds of materials are around and how they're marketed. And if you were to design a new product, would you change the type of product you're labeling it as in order to add value to the marketing? All right, moving forward, how do you design a chemical product? As with pretty much all design process, there's a loop. And you may not have really picked up on this in process design because it's a lot to take in. But generally, we iterate things. So I'll start by listing the steps, and then we'll look at the way they look in a loop. So the first step is always to look at the needs of the customer or the client or the community. And then next, you generate ideas about how to fulfill those needs. When you've got a lot of ideas and you've evaluated them, the whole process of evaluation leads you to select one or several ideas to take forward. And then finally, you actually go ahead and manufacture that product. And as I said, we generally look at these things as loops. And so if we'll start with a customer need and take it to an idea. Take that through to a selection process. And finally, manufacture. And so how do you close the loop? Well, once you've manufactured one product, generally along the way, you've seen that there are more needs and you can develop the next line of product to extend the original functionality of your product. So it is a loop in that respect. But there's also some subloops here, and a lot of that is between the selection and ideation process. And so you select something, or you start to select something, and then you realize it doesn't really meet all the needs. So you might even need to iterate this way. Take a selection and then go back and reevaluate the needs of the customer, because engineers don't always think the same way consumers think, and that's just a fact. The thing is that entire part of the loop, which I'm going to circle in yellow here, this whole part of the loop can take a lot of time and manpower, and that's expensive. So you kind of have to decide at the beginning of a product design how much you're willing to iterate in order to get something to the point of manufacture. And that requires making really educated guesses about timeframes that you don't really have a lot of information about. So uncertainty is embedded in the process of chemical product design. So this is all I wanted to say in the introduction. For the rest of the lectures, we're really going to focus most on the first three parts, how to articulate needs, ideas, and make selections, because the manufacturing is very much related to process design, which you already are quite familiar with. So with that, I would like to thank you very much for your time today. And I will see you in the next video after I have finished enjoying one of my favorite chemical products. Have a great day. Take care.